Good morning. Thank you. I'd like to start to say thank you for the invitation to be here today to the FiSTT annual conference for 2025. I'm very sorry that we can't join in person, but really pleased to have the opportunity to join by video. So my name is Tim Deans. I'm joined here today with my colleague Sean Ashton. We're from a company called Nivalis, who specialise in a process called ice pigging. And over the next 10 to 15 minutes, I'm keen to give you an introduction to what ice pigging is, how and why it is used in the water industry, and also how we're looking to introduce the technology to Finland. At the end, there'll be an opportunity for questions and answers, and we'll be pleased to discuss any of the topics that you may have. So I'd just like to start by giving an overview of what ice pigging is. I can imagine that some of you may have heard of it, but probably the vast majority haven't. So ice pigging is a novel, innovative pipe cleaning process that uses a two-phase liquid, ice and water, to clean pipework. So the ice pig itself is composed of very small ice crystals. So it's not a solid lump of ice, it's not large ice cubes, it's very small ice crystals. So typically the crystals are less than 0.5 millimetre in diameter. The best way I can describe this, and I apologise, it's not very technical, and my colleagues will often cringe at me, is it's like a slush puppy drink, a slushy drink. I don't know if that translates particularly well, but it's one of the slushy drinks that children will often drink, really, really thick and packed full of sugar. Instead of the sugar, though, we're using the salt. So the ice is this thick ice flow that we can pump like a liquid, but it will form in the pipe as a semi-solid, as a plug. And you can imagine then it can flow through obstructions. It could be a valve, it could be a change in diameter, bends, a sensor in the pipe, but it can move through the pipe as a plug, having high wall shear stresses at the pipe wall and cleaning effectively. As a result of the matrix of the ice and the liquid, it can also entrain contaminants and debris within the ice pig, and then carry it from the pipework. The diameters that we can pig range hugely, so we can go down to really, really small diameters, say 8 millimetres, up to say 600 millimetres of pipe. In the water industry, we're typically on ranges perhaps between 150 and 450 millimetres typically. As I mentioned, we are using an additive within the solution, so we use salt at a concentration of typically 5%, so just slightly higher than seawater. And within the water industry, that has been approved as a safe and easily detectable option. In different industries, we can use different additives, again, that are approved for those industries. So why does ice pigging work? So hopefully you've got the concept of what the ice pig is and how it can flow through the pipework. Well, it's this special rheology that allows the ice pig to flow as a liquid but move as a solid. So this plug in the pipework is offering many, many, many times more wall shear stress than equivalent water flushing. So just a note on water flushing: to get effective cleaning using water flushing, you have to have really high flow velocities, and the numbers that are often quoted could be 1.5 metres per second and above in order to get the level of turbulence. That's often possible in smaller diameter pipes, but the pipework that we're going to be talking about today in the water industry are much larger, and it's really hard to get those flow velocities. The ice pick, however, is really well suited to those large diameter pipes. It will form as a plug, it can move through really, really slowly, but still offer those really, really high levels of cleaning. The graph is just a quick graph to show cleaning effectiveness on the vertical y-axis against ice fraction on the horizontal x-axis. So if on the far left, in the far left corner, at zero, effectively zero ice fraction, which would be your water flushing, compared to at the grey end, you can see where we've got ice that would be suitable for ice pigging. You can see that there's an exponential like increase in cleaning effectiveness. And we don't need, as I mentioned, a high flow velocity. So this high shear rate leads to high and efficient and effective pipeline cleaning, which of course then leads to time saving and improved process quality. So I hope that's a bit of an overview about why it works and why it is so effective and why we don't need the high flow velocities. So just a bit of background for those that may be interested. So it was developed only 20 years ago in the University of Bristol in the UK by Professor Giuseppe Cruini. He wanted a new concept to be able to clean pipework much more effectively than water flushing or conventional pigging. With water flushing, the high flow velocities; with conventional pigging, the infrastructure required for insertion points and removal points and some of the problems associated, and he came up with wanting to put something thick that could flow but wouldn't contaminate the pipework. And he had the brave wave moment, ice. If something were to happen, it were to get stuck, at the end of the day, it will just melt. So from the concept at the University of Bristol, and I was fortunate to work with Professor Carini, he was my mentor, my supervisor for my PhD. Ice picking has been developed over the last 20 years to where it is now. So initial scaling was focused in the water and municipalities, initially in the UK, in Bristol, where I'm presenting from today, but quickly moving throughout the UK and internationally into the United States, Japan, Australia, Czech Republic, Spain, Singapore, and others. It was quickly adopted by Suez, a multinational company focused on water, recycling, recovery, who further commercialised technology and began introducing it into new industrial sectors, so manufacturing sectors, paints, surface coatings, food and beverage. We fast forward to where we are today, and as I mentioned, I'm here today with my colleague Sean as part of Nivalis, and we're a focused research and development engineering business who solely focus on ice picking. But again, we're working in more and more industries, and now defence, maritime, oil and gas, pharmaceutical, but as well as those other previous industrial sectors I mentioned. And of course, the water industry remains one of the key areas that ice picking is used due to the huge benefit that the technology can add to those industries. I put on the presentation a note 2023, Watercom, our partner in Estonia, and I'll touch on that later as a specific case study. So ice picking in the water into itself, so we've touched on how effective it can be at large diameter pipes. That's one of the key messages really for why it is so effective. So drinking water pipes will always suffer from issues. So it could be biofilms, it could be sedimentation, it's been caused from some change in a network, it could be rezoning resulting in different flows, or for example, it could be a burst that results in discoloration of the customer's tap. So ice picking has been proven over the last 15 years really to be highly effective at removing the sediments and the biofilms that cause these problems. It's a very efficient clean, it's non-aggressive, it won't cause damage to the pipe wall. We don't need the high flow rates, so low flow rates, low operating pressures, and it can clean long pipe lengths in a single clean. So we're not talking meters, we're normally talking several kilometres per ice picking clean. It's not just effective for cleaning water pipes, but also wastewater and sewer pipe work that can be pressurised. So just to touch quickly on the process, just to give you an overview how it works. It's a single pass, so your ice, you can see in the photograph there, an ice tanker will turn up on site, connect to the main, connect to a pipe fitting that would often be there, for example, a fire hydrant. The main would be isolated, the ice being pumped in under pressure. Once in the pipework, the main opened up and the water within the pipework will be used to propel the ice pig through the water main at mains pressure. The ice pig will then come out at the outlet point again through a standard fitting. Again, it could be a fire hydrant or an air fitting. Out at the outlet, often through some monitoring equipment where we can detect the ice pig and contamination using temperature, conductivity, pressure, turbidity. The ice waste can be then collected within a tanker. Once it's all been removed from a pipe, the pipe can be further flushed and returned to service. A very quick, straightforward, single pass. So now moving on to what the key benefits are within the water industry. I've touched on some of them just to go over those. The high shear rates offer that superior cleaning efficiency compared to equivalent water flushing. It really is a true no-dig technology. It's minimally invasive. If the inlet and outlet points are already in situ, there's very little enabling work, so no damage to pipework or the local environment. Reduction in water usage compared to conventional methods I've touched on. It's a single pass. You're not having to flush for hours or days on end in order to try and remove the discoloration. The ice pick itself is not abrasive. It's a gentle clean, but many, many times more effective than the water flushing, so it's non-aggressive. It's also, and I touched on this earlier from Professor Joe Cree's initial concept, it's low risk. If for whatever happened, there was an issue, let's say a valve was passing and it ended up being stuck within the system, go and have a cup of tea and wait, it will melt, it's ice. Being a single pass, it's quick, so typically 2 to 3 hours, as long as it takes to pump the ice from the injection point to the outlet point, and of course leading to shorter downtime and reduced customer outage time, so happier customers at the end of the day. I've touched on comparison to water flushing, but it's also other technologies, so it's less disruptive than foam swabbing, so you don't need those enabling works for a conventional pig or swab. It's more versatile than air scouring. Air scouring can be very effective, but it can also be quite aggressive and limited on distance. The ice pick is also very effective for complex pipe networks, so where you've got different diameters or different fittings or bends within the system where you can't use other cleaning techniques. So it offers that flexibility and versatility to use it for cleaning pipe work that may not have traditionally been cleaned using other techniques. So I just want to touch briefly on a case study. So Watercom, our partner in Tallinn, Estonia, approached us and we listened to them to understand what they needed from an ice pigging solution in order to clean the pipework they have within Tallinn and wider within Estonia. Focus was to improve the network cleaning efficiency, including lots of old cast iron pipework found in the city. So we worked with them, produced equipment. This was delivered in 2023, where we provided training and worked with them to get the system up and running. And they have worked fantastically with the equipment. And just this year, just gone, 2024, cleaned 145 kilometres of pipework using ice pigging. So a huge amount cleaning with ice pigging, cleaning with ice every week, week in, week out. And as a result of this, they've seen improved pipeline efficiency and water quality. They've seen and experienced and shared the environmental benefits through reduced water usage and water waste, and are pleased to have a reliable, repeatable cleaning system for cleaning the infrastructure. And it's an ongoing collaboration with us, and Sean and I are very fortunate to be part of that partnership for the service and optimisation of ice picking within Estonia. And that leads us on to say, we're working in Estonia, we're keen to work with you here in Finland. And again, to say thank you again for the opportunity to give you a bit of information about our ice picking technology and how it can offer potential benefits within your industry. So I'm here today with colleague Sean from Nivalis. We're a specialist in ice picking technology. We're committed to research, innovation, sustainability and client support. We're based in the UK, but we work worldwide, and we're always happy to come and meet you, discuss what's going on, and where necessary, we can provide on-site customer demonstrations. So we have equipment that we can ship all over the world. We can ship equipment to Finland, carry out some demonstrations of the technology. We're keen to support you in here and the Baltic States, partnerships, offering different solutions for your infrastructure to understand what you require, and I've mentioned the training and technical support that we can offer. We've also proven the equipment in different environments, particularly in Estonia, here in Finland, in the colder climates. So really, I'd like to say thank you for your time today. I hope that's given you a bit of an insight into ice pigging, the process, what it is, how it works, and some of the real benefits that we've seen in the water industry. It's been vastly proven in the water industry throughout the world as a really, really good technique to be able to provide quicker, faster and better cleaning. So thank you again for your time, and Sean and I would be pleased to take any questions. If, however, you think of something afterwards or you don't get around, please do visit our website, and there's an email address on there, so do get in contact. We'll be able to provide further information. So thank you again.